Okay, we're up to section 3536, test review. It says solve each system with whatever method you choose. So we have elimination or substitution. We'll talk about that during the review. It says if there is a solution, which means there could be no solution, you got to find your answers and then add them together. That's just so when you guys take the test, you don't take the potential answers and just plug them in and see which ones work without actually doing the math. This one, because my x's, y's, equals, and constants are lined up, I'm just going to use the elimination method. So what I'm going to do is take that top one and slide it over. I could divide this one by 2, but that would actually work against me because I can see that these two x's are lined up real nice. So I'm going to multiply this by -1. Distribute, distribute, distribute. So I get -2x plus y equals -1. Add them together so these cancel. So I get -y equals -5. So positive y equals +5. I can plug this in anywhere I want. I can plug it in here, 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 or here. I'm going to pick this one because it looks the easiest. 2x minus whatever y is, which is 5, equals 1. Now I'm going to add 5 and add 5. So I get 2x is 6, divide by 2, divide by 2. X is 3. So there's my answers. So technically my answer is 3, 5, because we're looking for the intersection point of these two lines. But they're saying take your x and your y and add them together. So 3 plus 5 is 8. How about this one? Well, this one I'm going to add x to both sides. I'm just concentrating on that equation up there. So I get 4x plus 3y equals 5. Now I'm going to subtract y from this side and subtract y from this side. So I get 2x minus 5y equals -17. On this one, I can look at my y's. I'd have to multiply this by 5 and this by 3. But on this one, to eliminate x's, I just have to multiply this one by -2. So I'm going to choose that one. So if I distribute, 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 I would get -4x plus 10y equals 34. I'm going to slide this one over just so you can kind of see what I'm doing. Now I'm going to add these together, and if I do that, I eliminate the x's. So I get 13y equals 39, divided by 13, and I get y is 3. I'm going to plug this in the easiest place that I can find, so I'm just going to plug it in here, and so I get 4x plus 3 times whatever y is equals 5. Now that's 9, so I'm going to subtract 9 from both sides. So I get 4x is -4, divide by 4, divide by 4. I get x is -1. So there's my x, there's my y. If I add those together, I get 2. Now this one's a little unique because my x's are lined up, my y's are lined up, my constants aren't on this side, but they're still lined up. Equals 0. So I can go ahead and add these right now because I can see that my y's are going to eliminate. So if I add those together, I get 5x minus 15. 0 plus 0 is 0. If I add 15 to both sides, I get 5x is 15. Divide by 5, divide by 5. I get x is 3. Now I'm going to go ahead and plug it in that top one. So I go 2 times x, which is 3, plus y minus 7 equals 0. So this is 6. 6 minus 7 is -1, so I'm just going to rewrite it as y minus 1 equals 0. Add 1, so I get y equals 1. There's my x, there's my y, add them together, I get 4. This one, we have a little bit of work to do. This is number 4. It got cut off by that. Distribute, distribute. So I'm going to get 3y plus 6 equals x minus y. Now I'm going to try to get my x's and y's over here. And just keep on using the elimination method. Seems to be working quite fine. So this is going to be a little bit of work, but I'm going to subtract x and add y. Subtract x and add y. But I'm also going to subtract 6 from both sides. And so over here I get -x plus 4y, these cancel, equals -6. I got the same amount of work to do over here, so distribute, so I get 6y plus 6 equals x plus 2y. But again, I'm going to subtract my x, subtract my 2y, subtract my x, subtract my 2y, get all the letters over on the left, get my numbers over on the right. And so if I take care of this, I get negative x, 6y minus 2y is 4y. These cancel, equals, cancel, cancel, negative 6. So if I go negative x plus 4y equals negative 6. If you're actually connected to this, you notice that these two are the same line. So if these are the same line, you're going to have infinitely many solutions. Or you could just say it's the same line. Let me pause this a second. And your back of your packet says all reals. So really, all three of these answers are the same thing, but this is the one that your packet says. This one I'm going to use substitution because I haven't shown it yet. So I see this little x sitting all by itself, so I'm going to subtract 2y, subtract 2y. I'm just concentrating on this now. I'm ignoring this. So that would give me x equals 1 minus 2y. What I'm going to do with that, notice this is what x equals, and I'm going to put it right there in the other one. That's why it's called substitution. So I get 3 times x, but x is 1 minus 2y plus 6y minus 4 equals 0. Now you see I've got one equation with just y. So I'm going to distribute, so I get 3 minus 6y plus 6y minus 4 equals 0. Notice these cancel. So I get 3 minus 4, and I get negative 1 equals 0. Now it's like, whoa, wait a minute. Is this true or false? Well, the variable we're trying to find disappears, and then we get a false sentence. And hopefully you realize this is no solution. And in the world of these problems, that means these two lines are parallel because they'll never intersect. Okay, which is kind of a nice segue for this next problem. Which two equations would produce a system with no solution? Well, no solution means they're parallel lines. Parallel lines means they have the same slope. So really, that's what this problem's asking you to understand. Which of these problems have the same slope? And if I just look at this, it kind of jumps out at me. I got y equals mx plus b with a 5 there, and y equals mx plus b with a 5 there. So it would be option 1 and option 4, Roman numerals. This next one might be a little more difficult, but this says which two equations would produce a system with all real solutions? Again, this problem gives us a good hint. It means they're the same equation. So what we're probably going to have to do is rearrange stuff. We can see that this one and this one are not the same. They have different y-intercepts. So if I take a look at this one, something should jump out at me. That's divisible by 3. So if I divide all of these terms by 3, I'd get y minus 4x equals 12. And if you look, this is the exact same thing as this. So that means options 2 and 3 are the same line. Now we're going to get into these story problems. But remember, story problems from earlier problems use one variable. Now we're going to use two variables, and we're going to make them into these sort of looking problems. So we're going to have to, just set up the story problem, then actually use substitution or elimination. Tickets for the homecoming dance cost $20 for a single ticket. So we could use X or we could use S. I'm going to use S for a singles ticket. And then I'm going to use C for a couples ticket. You could use X and Y and keep track of it, but I'm going to make this S and C. It just helps me understand what this is a little bit better. So what it says is ticket sales totaled $1,275. So what that means is, we define the variables, we just did that. Write the equation. Well, it's $20 for every single ticket. It's $35 for every couples ticket, and the total ticket sales were $1,275. Remember, we're talking money on that equation. Now it says write the equation. It should say the equations for the system, because that system means two equations. And here's where we're going to get our other one. 70 people attended. Now there's a little twist here. If you bought a single ticket, that means one person is represented by that one ticket. If you bought a couple's ticket, it's two people per couple's ticket. Remember, this is total number of people, and that equals 70. Now, before we just start using elimination, I want you to look at this and ask yourself, can we divide that by something? And the answer is yes. We're going to divide that by 4. So we're going to get 5s plus 7c equals, well, there I go, showing my humanity. We're not going to divide by 4. I would make excuses, but that would waste your time. We're going to divide by 5. So that's not what we're going to go with. We're going to go with 4s plus 7c equals 1275 divided by 5 is 255. Notice 4 doesn't go into this, and that's what caught me. So, little mistake, but no big deal. Let's keep moving. And then we're going to slide this over underneath it. S plus 2c equals 70. Now I'm going to go ahead and use elimination. I'm going to multiply this by negative 4. So I'm going to get negative 4s plus 8 plus a negative 8c equals negative 280. I'm going to bring this right down here. So 4s, forget about that little dot, plus 7c equals 255. Now these are the two that I'm going to add together because my 4s's will cancel. I'm going to get negative 1c equals negative 25, which means positive c equals 25. Now what is that? Well, it says how many tickets of each type were sold. So couples tickets, there were 25. Now, if you just want to figure out the singles tickets, we could plug it into that formula because that's the easiest one. So 1s plus 2 times 25 equals 70. So that's 50. So I'm going to subtract 50, and the number of singles tickets is going to be 20. So there's no way I'm going to finish this in the next minute and a half, 2 minutes. So I'm going to go ahead and end this part 1 and create a part 2. So we'll see you in 2 seconds.